of the in-between. Before we go there, I'd just talk a little bit about, doloids. What are doloids? Doloids are small, enclosed karst depressions formed by dissolution of the carbonate rocks. And to the history of karstology, the doloids were always considered as a diagnostic karst landform. There are also soil types. So you have a depression, and of course, soil gets trapped there, so it's accumulated at the bottom, and because we have soil at the bottom in the past, doloids are also used as field, so this kind of doloids is called cultural or cultivated doloids. And regarding the soil that you can find in the doloids is fine-grained city clay soils, humus soils to be exact. And you see this picture here in the bulldozer, so they can be up to a couple of meters. So, case study, we go from here to the most northern part of the Mediterranean, to the border region between Slovenia and Italy, actually to the part of Slovenia called the Caspian, or Germany, maybe more normally Germany is a karst. Karst in Slovenia. Slovenia is more than 50% composed of, let's say, karstic rocks, limestones, or mostly limestone, but also dolomites. So all these reddish, yellowy, greenish, and blue colors, these are the different types of karst that you can find in Slovenia. So you can see a huge part of Slovenia is karstic rocks. And because we have so much karst, we also have a lot of dolomites. So this reddish color, these are actually dots representing one dot is one dolomite. And altogether, because we have data for the whole country and we did some modeling, we calculated that in the country 470,000 dolomites. If you put this thing into the national scale, we have more than 20 dolomites per square kilometer. Or if you look just at the carbonate rocks, we have more than 50 dolomites per square kilometer. And one other thing, we don't have just a lot of karst, we also have a lot of forests. So more than 60% of the country is forested. So all the green color and the red color is forest in Slovenia. Basically, it is forest everywhere. Why? And I'm explaining to you this is because of this. So, I said before, there are more than 50 dolomites per square kilometer in Slovenia. This is how Slovenia looks from above. So forest basically everywhere, you cannot see any dolomites. But actually, the topography looks like this. It is a landscape, so dolomites basically everywhere, but difficult to see due to this high percent of forests that we have. Going to the karst plateau, as a case study, you can see the ones that are all dolomites, they look like this. So we really have a lot. Talking about the percent of forest that here in Slovenia, this is now. In the past, was much different, especially in this karst plateau that I'm talking about. So let's say in the Middle Ages and the beginning of the New Ages, there was in agricultural density increased, so there were farms, we got much more farms, and we got intensification of the land use. So the forest that was grown there in the Middle Age and the New Age, which was cut, mostly it was reshaped into pastures and meadows, and we got what we call sometimes the pseudo-steppe in our environment. But because these karstic regions are also marginal regions, and if you cut trees, you instantly get soil erosion, either by wind or by rain. So they cut the forest, soil is gone, and we got this barren rocky landscape. is more or less barren, some stony, some steppe. And what you see there here, so also in the 18th century, they get dollars, you can see here, this sort of features. So, how this landscape look like anymore? So, more than 100 years ago, the landscape looked like this. You can see bare landscape, a lot of rocks on the surface, and grassland. Today, unfortunately, this picture is not seen very good, but this is now all forested, as I mentioned before. So, at the beginning of the 19th century, grassland predominated in this region, more than 60% was grassland. Today, more than 70% is forested. Another feature from the late 19th century, transport of ultraviolet, you can see stone there, more or less with some shrubs and resin. Here is the tower, and this tower is, on this picture there you can see it is forest all around. What happened was, so in the late 19th century, they started to do reforestation on the region, and were very, very successful. So you can see now the whole place is forested. And then in the second part of the 20th century, because of the aggregation, also ecological succession falls. What we were trying to study was to see the difference between the forest in the plateau and in these towns. We used terrestrial glider and did some cross sections, and what you can see is the green color is ground, these depressions are lawns, and the blue color are trees. And what you can see is that basically the height canopy is the same if you are on the plateau or if you are in the lowlands. Why is this? This is because the lowlands have, first of all, more sediments, because they have more sediments. There is more moisture, and you also have more organic matter in the depression. This is why the trees are, let's say, they can grow faster and better conditions to grow. And this is just some examples of cross sections. You can see here the lines and the height of the canopy. Again, you see big line, the height of the canopy is the same as what it was all around. Some more examples. We didn't use just terrestrial data, we also used an aerial data, and there's also the same. Here is the point cloud of the height of the canopy, and you can see it's more or less the same height of the trees which grow in the line and the trees that grow outside. So you can see how much more favorable conditions are in the lines than in the surrounding plateau. We also took a look on the carbon stock, comparing the lines and the plateau around. You can see that the carbon stock in the lines is much higher than in the surrounding plateau. So the forest in the surrounding plateau, here the carbon stock is, let's say, 70 tons per hectare, but in the lines, either in the forest, either in the succession stages before, in the grassland, is in the line, the carbon stock is more than 100 tons per hectare, meaning the lines may be in the future mean to also one of the means to mitigate climate change. But lines are also microclimate oases. Why? Because the microclimate within the lines differ with the climate around and the surrounding plateau. You can see here that there is snow in the line, but around there is no snow. So you can see there are more cold conditions within the line than around, which make them, of course, they are cold air pools. As I mentioned, the microclimate within the line is possibly this air pool is different than in the surrounding plateau. What happens is, especially in the winter, during the clear nights, heavy cold air goes into the lines, into the depressions. In the depressions, it is also this cold air protected from the wind, so it stays there. And when the next day the temperature go higher around the lines, this light, more warm air does not mix with the air in the lines, so we get this cold air pools, which can extend for, let's say, a little bit longer. Why is this important? It's important with regard to the climate change is that in the lines they can sustain species which like, let's say, a little colder climate than we get today. And we consider them as micro refugia for this, let's say, cold event. Actually, we calculated or found out the lines that are at least 30 meters deep can serve as good safe haven for this cold Atlantic species. What is the climate in this part of Slovenia? So it is, we call it some Mediterranean. Actually, after the organization, it is the humid climate in short summers. Temperatures in the coldest month are above zero, in the hottest month are above 20 degrees, and there is the most humid part of the Mediterranean, more than 1,200 kilometers of rain. But we experience climate change, as you can see from these numbers here. So here are the long-term measurements of temperature, the annual temperature, here in the middle of the graph plateau from the 60s till now. And what you can see is in the 60 years, average temperature went up 2.4 degrees. And talking about precipitation in the same period decreased more than 200 millimeters. So in some areas here in Africa, the amount of precipitation we get in a year, we are using this we lost this amount of precipitation in the last 6 years. So what are we afraid of? We heard that this trend will go further. So climate will get warmer, climate will get drier. As you saw from this figure. So we may get back to this kind of environment in the future, but not because of deforestation, which we had in the past, but because the trees will actually not grow in the environment that we are getting into. And this is not too much. And this happened before. We know also from other regions in the Mediterranean, on the Greek islands, in the Dolomite, we have an endemic species, or the list of the Dolomite is actually in the name of the species, and this plant survived just in the Dolomites in high altitudes because it is this cold environment. Just before I finish, I mentioned so the climate is getting hotter, the climate is getting drier. With the drier climate, you also get more forest fires. Forest fires in the area in 2002, 200 hectares. What is really this forest? What is this reddish was burned? And why can I show this? Because of this we are in the aspect of all these round features are lawns, or red is burnt forest, what is not red is not burnt. And if you take a closer look, see the lawns. The forest, the trees in the lawns are not burnt, but they will burn around the lawns. So what we can see here is obviously the lawns seem to be less vulnerable to forest fires than the surrounding plateau. Why is that? I still cannot answer because this is work in progress. We started to work on this topic, and I will stop here.